Good morning, dear students. Welcome again. In last class, we have already discussed regarding rate of reaction. In this lecture, we will discuss how the rate of reaction can be determined for any chemical reaction with the help of their stoichiometry. So today, my heading is expressing the rate of reaction in terms of different reactant and products. Consider following reaction, that is N2O5 after heating to produce NO2, nitrogen dioxide and oxygen gas. In this reaction, we can say what? The rate of disappearance of N2O5 is just half of the formation of NO2, and the formation of O2 is 1/4 the rate of formation of NO2. So we can write what? Rate of disappearance of N2O5 is equal to what? Minus d N2O5 divided by dt. D by dt is said to be what? In terms of instantaneous rate. Negative sign indicate what? This chemical become disappearance. Rate of formation of NO2. We can write what? Plus d NO2 by dt. Similarly, rate of formation of O2. Again we can write plus d O2 by dt. If we want to determine the rate of reaction and rates are equal, then how it become possible? So for this, to get an identical value of the rate of reaction in terms of any reactant or product, the rate as expressed above further divided by the stoichiometric coefficient. Thus, for above reaction, we can write what? Minus d N2O5 divided by dt into 1 by 2 is equal to plus d NO2 by dt into 1 by 4 is equal to plus d O2 by dt. All rates become equal. Is equal to what? Rate of reaction. So in this way we can predict the rate of reaction. This term is known as what? Rate of disappearance. This term is known as what? Rate of appearance, or you can say rate of formation. This term again said to be what? Rate of formation, or you can say rate of appearance. So in nutshell we can write what? Minus d N2O5 upon dt is equal to 2 into the rate of reaction plus d NO2 by dt is equal to 4 into rate of reaction plus dO2 by dt is equal to 1 into rate of reaction. Both terms are called what? This term is known as what? Rate of disappearance, and such term called what? Rate of formation. So all rates are not become equal if their stoichiometric coefficient are different. Consider following general chemical reaction, that is a small a, a small b, a small c and a small d are a stoichiometric coefficient of reactant and products. So we can write what? Rate of reaction minus dA upon dt into 1 by A is equal to minus dB by dt into 1 by V is equal to plus dC by dt into 1 by small c is equal to what? Plus d capital D concentration by dt into 1 by d. So rate of reaction become equal if stoichiometric coefficient are involved. Such term are known as what? Rate of reaction. If coefficient are not involved, then the left part here is said to be what? Rate of disappearance, rate of disappearance, here rate of appearance, and again rate of appearance. So for any chemical equation we can determine rate of reaction. Now we will discuss some simple questions based upon rate of reaction. Our question first. The rate of reaction is expressed as plus 1 by 2 delta C by delta T is equal to 1 by 2 delta D by delta T, 1 by 4 minus delta A by delta T is equal to minus delta B by delta T. What will be the reaction? So such relation is said to be what? The rate of reaction. So we can write what? A and B are called reactant and C and D are called what? Product. So if a stoichiometric coefficient is removed and multiplied by 4, that is said to be what? 4 mole of A. Similarly, 1 mole of B gives 2 mole of C and 2 mole of T. Why? Because if dA by dt is multiplied by 1 by 4, give the resulting value what? 1. So all the stoichiometric coefficients then equal. So this is our reaction, or you can say equation, and this is a way to write the rate of reaction. Similarly, question second. In the reaction A plus 2B gives 6C plus 2D. If the initial rate minus delta A by delta T at T is equal to 0 is 2.6 into 10 to the power minus 2 m per second. What will be the value of minus delta B upon delta T at T0? So in this question, we have to find out the rate of reaction for what? B. Minus sign indicate disappearance and plus sign indicate appearance. Delta by delta T is said to be what? Average rate. So always remember, rate can either express in terms of average rate or instantaneous rate. So for this reaction, we can write what? A rate of reaction is equal to what? Minus delta A by delta T is equal to minus 1 by 2 delta B by delta T is equal to what? Plus 1 by 6 delta C by delta T. Again you can write plus 1 by 2 delta D upon delta T. So this term is given and we have to find out the value of what? This. So we can write what? Minus delta B by delta T is equal to 2 times of minus delta A by delta T. And this is given, that is equal to what? 2.6 into 10 to minus 2. So we can write what? Minus delta V by delta T is equal to 2 into 2.6 into 10 to the power minus 2 m per second. 5.2 into 10 to the power minus 2 m per second. So this is your answer for the value of what? Average rate of reaction for reactant B. Our next topic is factors affecting the rate of reaction. There are so many factors in which our rate of reaction depends. So my heading is factors affecting the rate of reaction. There are so many factors in which the most important factor is temperature. You know very well, rate of reaction is directly proportional to temperature. Why? Because we know that when temperature increases, it means what? Kinetic energy increases. When kinetic energy increases, it means velocity of particle increases. Velocity of particle increases, it means number of collision increases. Hence, effective number of collision increases. That's why we can say rate of reaction increases when temperature is increased. Generally, 10 degrees centigrade rise in temperature, rate of reaction become doubled or lies between double to triple. So we can say what? Rate of reaction directly proportional to temperature. When temperature increases, kinetic energy increases. Kinetic energy increases, it means what? Velocity of particles increases. Velocity increases, it means number of collision increases. Hence, effective number of collision increases. Therefore, rate of reaction what? Increases. Generally, it is found that every 10 degrees centigrade rise in temperature, rate of reaction become 2 to 3 times. You know one thing, mu is equal to kT plus 10 divided by kT. This mu is called what? Temperature coefficient. Temperature coefficient is defined as the ratio of rate constant of reactants at two different temperatures. Two different temperature. Differing by 10 degrees centigrade. If temperature is not given, if T is not given, then generally 25 degrees centigrade is to be considered. 25 degrees centigrade temperature is known as what? Room temperature. So absolute temperature plus 10 divided by normal temperature kT. This ratio is said to be what? Temperature coefficient. And generally 10 degrees centigrade rise in temperature, our rate of reaction become what? 2 to 3 times. Our next factor is concentration. Concentration of reactants. The rate of reaction is directly proportional to concentration. More concentration means more collision. More collision means rate of reaction become faster. Next one, nature of reactants. A point, physical state. There are 3 states are available: solid, liquid and gas. Gaseous reactions are more faster compared to liquid reaction. Liquid reactions are more faster compared to solid reaction. Solid reaction are slower. Why? Because due to strong intermolecular attraction between particles. So we can say what? Rate of reaction order: gas, liquid, then solid. B, physical size. Physical size means more surface area, rate of reaction become what? Faster. So we can say what? If we take solid calcium carbonate and powdered calcium carbonate, the rate of reaction of powdered calcium carbonate become faster compared to solid calcium carbonate, because powdered calcium carbonate have got what? More surface area. Rate of reaction directly proportional to surface area. C, chemical nature of reactants. Ionic reactions are more faster compared to covalent reactions. If number of bonds in reactant size is greater, then reaction become what? Slower. So how our chemical reaction is given? The rate of reaction depends upon the chemical reaction. Suppose 2NO plus O2 gives 2NO, and the second one 2CO plus O2 gives 2CO. This reaction becomes faster and this one becomes slow. Faster reaction, slower reaction. This reaction becomes slower. Why? Because in carbon monoxide, more number of bonds present compared to NO. If number of bonds in reactant side become more, then more energy will be required for breaking such bond. That's why we can say rate of reaction become what? Slower. Our next factor, fourth, pressure. There is no effect of pressure for solid and liquid phase reactions. But if reactions are in gaseous phase, then gaseous phase reactions, we can say when pressure increases, rate of reaction increases. So we can write what? Rate of reaction directly proportional to pressure for gaseous reactions. Fifth number, light. In presence of sunlight, rate of reaction becomes faster. Why? Because activation energy decreases. Lower the activation energy, reaction becomes faster. Rate of reaction directly proportional to what? Exposure to light. Sixth one, catalyst. In presence of positive catalyst, rate of reaction increases. In presence of negative catalyst, rate of reaction decreases. So rate of reaction directly proportional to positive catalyst and inversely proportional to negative catalyst. Seventh, dielectric constant. This term is applicable for solvent. For solvent, if dielectric constant is higher, then ionic reaction become what? Faster. The last one, pH. pH also affected the rate of reaction. Suppose this reaction is given FeCnO6 4 minus gives FeCnO6 3 minus. This reaction proceed in acidic medium. So we can say in acidic medium product become obtained. Why? Because rate of reaction become faster. So such are the factors in which our rate of reaction depends. Thank you.